I'm going to rewrite this into y equals mx plus b, and then I'm going to state the slope and the y-intercept, just like I did before. So since it's not in y equals mx plus b, I've got to solve for y, so I've got to get y by itself. The way I'm going to get y by itself is getting rid of this negative 3x portion. So what I'm going to do is I'm going to get rid of that by adding the 3x to both sides. So what this makes it say, those fall out, and I get y equals, I wanted to say mx plus b, so I'm going to write the x part 3 first. 3x plus 5. Now what I'm going to do is I'm going to take out my m and my b, and I'll write y equals mx plus b underneath here again, so that you can see that my m is 3 and my b is 5. Remember that b stands for the y-intercept. When you graph using slope and y-intercept, you need to start with a point. This is a point. You need to graph this first. So we're going to write that. Graph first. Where is the y-intercept? Well, it's on the y-axis, and it's 5. We've been doing that when we graph the x and y-intercepts, but now we're just graphing the y-intercept. I don't have the x-intercept. I could find it, but we're going to graph it using slope. Slope is going to be defined as rise over run. The problem is this is not a fraction, so we're going to make it a fraction of 3 over 1. So that way I have a rise and I have a run. So from the point that you created, you want to rise 3, so you count 1, 2, 3, and then you run 1. Now it is a positive 3, so we went up 3, and it's a positive 1, so we went to the right 1. If you went down, that would be negative, or if you went left, that would be negative. So we have a point right here. So I counted up 3 and over 1. Now I'm going to go ahead and mention this because it's going to be important for later. Another way we could describe a slope of 3 over 1 would be negative 3 over negative 1. The reason why that is because a negative over a negative is a positive. How would I graph the slope negative 3 over negative 1? Well, I'd start at the 5 again, and instead of going up 3 this time, because it's a negative, I would go down 3. 1, 2, 3. Because it's a negative 1, I would go left 1 instead of to the right 1. So I would have a dot here as well. Notice how it connects with these other ones and makes a straight line. You could continue graphing and going down 3, to the left 1, many, many times so you could get even a more exact line. I'm going to graph multiple points so you guys get used to that as we continue through some of these graphs. The next example, the first thing we always want to do is put it in y equals mx plus b form. So we're going to solve for the y. We're going to do that by subtracting 2x off both sides. When I do that, I end up getting y equals negative 2x plus negative 3. I'm going to write y equals mx plus b underneath here. I see that my m is negative 2, and I see now that my b is negative 3. We know we're supposed to graph this first. Graph this first. This says my y-intercept. Remember this means y-intercept. My y-intercept is negative 3. There it is. The second part to this is my slope. My slope just says negative 2. I need to say it as a fraction, negative 2 over 1, so that we have a rise and a run. The other fraction that goes along with this, I'll talk about here in just a second. Let's go ahead and do this. Rise, negative 2, which actually means I'm falling 2 and running 1. I could do this many times. Fall 2, go to the right 1 because it's over positive 1. Fall 2, go to the right 1. The other fraction that goes with this would be 2 over negative 1. 2 over negative 1 is still a negative 2. Don't put another negative with it because then that makes it positive. But 2 over negative 1 is still a negative. I could start here and I could go up 2. That would be positive 2 over negative 1. I go to the left 1. Up 2 to the left 1 is negative 1. Notice how I get a straight line. I know I have the right answer too. Look at this. A negative slope does go down, and I had a negative slope as my answer.